All right, we're doing our pulley worksheet. Number 1. We have a single fixed pulley is hung from the ceiling. The pulley has a diameter of 12.5 centimeters. The load is 0.196 newtons. The actual effort is 0.2 newtons. So we just want to create our drawing. So basically you have your pulley that's hanging here from the ceiling, right? That's going to have some sort of rope hanging over the top. It has a diameter of the pulley equal to 12.5 centimeters. The load, so this is my load, or my resistance force, is equal to 0.196 newtons. And the actual effort that I'm pulling down with right here is equal to 0.2 newtons. Okay, so part B. What is the IMA? Okay, basically for a fixed pulley, it's just 1 because my effort and my resistance distance are just the radius. And there's just one rope, one strand supporting the load. So the IMA is just equal to 1. There's no math involved. What is the actual mechanical advantage? AMA is still equal to the force ratio of resistance over effort. The force resistance was 0.196 newtons. The effort was 0.2 newtons. 0.196 divided by 0.2, and we get 0.98. The AMA and D, we're going for efficiency. Efficiency is the AMA over the IMA, which is 0.98 divided by 1. We don't need a calculator, it's just 0.98 or 98%. All right, there's number 1. Easy peasy. Number 2. A single movable pulley is hung from the ceiling. The pulley has a diameter of 12.5. The load is 0.5 newtons. The actual effort is 0.26 newtons. So now we've got our ceiling up here that we're hanging from. Right. So, oops, I'm going to put my ceiling wrong way. Sorry. So now we're going to be pulling up around this pulley that's sitting in here. Should have drawn the pulley first, so I got it in there better. So I should get up here to number 2. We're going to have the load hanging off this spot. The load in this case is 0.5 newtons, so that's my resistance is 0.5 newtons. Here's my effort force, which they said is 0.26 newtons. They're giving me the diameter is 12.5 centimeters. So there's my scale drawing, so that's A. So B, what is the ideal mechanical advantage? Well, now I have 2 ropes supporting the load, and now this kind of acts like my fulcrum right here where it attaches across this imaginary lever right here. Okay, and so now my overall effort force, from my resistance force here, so the distance is twice as much for my effort, so my mechanical advantage is just always 2. And we know that because there's also 2 strands supporting the load. So again, no math involved. What is the actual mechanical advantage? The AMA is equal to my force resistance over my force effort. Force resistance was the 0.5 newtons. The force effort was the 0.26 newtons. So we have 0.5 divided by 0.26, and that is 1.92. Or just 1.9. And D, then we're going to have the efficiency, I'm not sure I put an equal there, is equal to the AMA over the IMA, which is equal to 1.992.29 divided by 2, and we get 0.96 or 96%. Number 3, it says a construction crew lifts approximately 560 pounds of material several times during a day from a flatbed truck to a 32-foot rooftop. A block and tackle system with 50 pounds of effort force is designed to lift the materials. What is the required mechanical advantage? So we have a construction crew, we're lifting things up, and let's write down all this info here. 560 pounds of material, so my force resistance is the 560 pounds of that material that I'm lifting from a flatbed truck to a 32-foot rooftop. Okay, so I don't know if any of that really makes a difference. The block and tackle system with a 50-pound effort force, so my effort force is 50 pounds. And what is the required mechanical advantage? So the AMA is just the force resistance over the force effort, which is what they gave me. 560 pounds over 50 pounds. 560 divided by 50. And we get 11.2 as my AMA. And then it says how many supporting strands will be needed in the pulley system. Okay, so we're basically looking for IMA. So when we have our block and tackle sitting here and the strands going back and forth because there's multiple wheels here, right? So there are more strands going. Remember, to get IMA, we count the number of strands. Well, if we had 11 strands, it's not quite enough. We can't have 0.2 of a strand, so it's either got to be 10, 11, 12, 13, some whole number. But 11 won't quite do it, right? 11 would only give me 550 pounds. We couldn't do the job. So we're going to need at least 12. Okay? 13, 14, 15 would also work, just meaning there's more friction. So with 12 strands, I should be able to lift 600 pounds, correct? Because 50 times 12 is 600 pounds, so there's 40 pounds of friction in all that if I just had 12 pounds. If I had 13, that means I'd have even more friction. But anything greater than 12 would work for that one. Okay, so number 4, a block and tackle system with 9 supporting strands is used to lift a metal lathe in a manufacturing facility. The motor being used to wind the cable in the pulley system can provide 100 pounds of force. So my effort is 100 pounds, because that's the motor that's pulling it up. What is the mechanical advantage? Well, they don't really tell me AMA or IMA, but they didn't give me enough. So we're just going to go with IMA because it did say that it had 9 strands. So A is just 9. And B, what is the maximum weight of the lathe? Okay, so now we have to look at this. When we're doing this, we know our mechanical advantage is 9. And again, it doesn't really tell me anything about whether it is ideal or not ideal. So that's the only mechanical advantage I have. That's now we're just going to have to say mechanical advantage is force resistance over force effort. And we have everything, right? We have the effort force and we have the mechanical advantage. So we can say that force resistance is equal to the force effort times the mechanical advantage, which is the 100 pounds times 9, which is 900 pounds. Okay, so that's the maximum weight I could think. And maximum, it's IMA, right? Because just like this, maximum could have been 600, but we didn't quite lift that because of the friction. So maximum does imply that we would be using an IMA. All right, I'm going to stop at number 4 there, and I'll make a second video for some of the others so we don't get too long.